Yeah, welcome back to YouTube classes. Dear students, in last two classes, we have discussed about the electric potentials topic, in which what is the potential difference, thereafter potential due to a point charge, potential due to a dipole, expression for potential due to a dipole, and thereafter, okay, potential due to the system of charges. Like this, we have derived the few of expressions and we have studied about the definitions of electric potential and potential difference. Okay, thereafter, here our next continuation topic is nothing but equipotential surfaces. Equipotential surfaces. Sir, what is the equipotential surface? Means this is a simple definition. First of all, potential. Potential means what is the definition? Work done to bring the unit positive charge from infinity to a given point in the electric field, of course, against the electrostatic force of field. Now that is said to be here potential. Now what is the equipotential? In name only there is a meaning. What is the meaning? Means equi, that means equal. Potential, equal potential surface. That means equi means same. We can tell same. Same potential surfaces. Equi, constant. Constant potential surfaces is nothing but equipotential surface. Once again, we just look at here. What is the definition of equipotential surface? Means, okay, equipotential surface is the surface on which electric potential is constant. Electric potential is constant. Constant means same. All points, that means at all points on it. You just add it here, at all points on it. Suppose if you take it a surface, on that surface, if you take any 2 points, at those 2 points, if the potential is same, means such a surface is said to be here equipotential surface. Such a surface is equipotential surface. For example, if you just look at here, what I am going to explain here means potential is equal to what we can write? 1 by potential due to a point charge, 1 by 4 pi epsilon naught q divided by r is nothing but expression for electric potential. Okay, now thereafter, here potential is inversely proportional to distance, inversely proportional or reciprocal to the distance. That means if the distance from the charge increases, potential becomes decreases. Okay, now according to this, with respect to distance, we are going to tell whether there is a potential is more or less. We can tell that. Next one. Thereafter, if you take any one surface, now here I am going to take one plane surface now. Okay, on this surface, here how many points I am considering? Here there is a 1 point, here there is another point, here there is another point. 3 points I am getting. At point A, potential is nothing but VA. At point B, potential is nothing but VB. At point C, potential is nothing but VC, V suffix C. If VA is equal to VB is equal to VC, means at any point on this surface, if the potential value is equal, same, constant, then such a surface is called here equipotential surface. Right? Now, here equipotential surface is nothing but, okay, the surface on which, on this complete surface, wherever it may be, at whatever the point on the surface, if the potential is constant, means, okay, any points you take it, at every point, if the potential is same, means such a surface is said to be here equipotential surface. Okay, now this is about the equipotential surface. Now thereafter, just now I have told V is equal to 1 by 4 pi epsilon naught q divided by r. Actually, this equipotential surface means potential is same at all points on the surface. Potential is same at all points on the surface. Now we will see here, sir, how to draw the equipotential surface in different cases. In case of point charge, in case of uniform electric field, in case of dipole, and in case of like charges. Okay, in these cases, how to draw? Let me see. How to draw? Now, first you take it. Sir, here equipotential surface. How to draw in case of a positive charge or in case of a point charge? You may take positive charge or negative charge. The difference is nothing but direction itself. Now, you just see here. This is nothing but one point charge I have taken. This is the positive point charge I have taken. Now, from this positive point charge, here at a distance r, here I am considering one point. And thereafter, here same distance, at a distance r, I am considering another point. Here at same r distance, one more point I am considering. Here also I am considering one point, same r distance. Here to here, the distance is nothing but r like this. Here another r distance point. Here also like this only. Here also like this only. Here also like this. That means from the point charge at a distance r, in all directions I have considered a distance r. Now you make them to join all the points which I have considered here. Okay, you just make them to join. Then what you may get, you just see what kind of shape you may get means you may get a kind of shape which is nothing but spherical shape you may get here. Now this is nothing but. Now here whatever the shape I have drawn here, this shape is nothing but equipotential surface. This complete shape is nothing but here equipotential surface for that point charge. Now here wherever it may be, at this point, 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 wherever it may be on this spherical line or on this spherical shape, wherever it may be, that means on the line wherever it may be, if you take the potential is same means, then that is said to be equipotential surface. So for point charge, now this is nothing but equipotential surface. Actually, you just see students here, sir, what is this direction means? This is the positive charge. From the positive charge, the direction of electric field is nothing but what we can write? Radially outward or away from the charge. Now, if you increase the distance, if you increase the distance means still you may get another spherical. Now this is the first spherical surface, this is the first equipotential surface, this is the second equipotential surface. Right? On the surface, here, wherever it may be at equal distances from the charge, if the potential is same means, then that surface is said to be here equipotential surface. First one is nothing but A and second one is nothing but B. VA is not equal then with VB. Why? Because here VA distance is lesser, VB distance is greater. Now this is first equipotential for this point charge and B is nothing but second equipotential for charge. That means what is the equipotential surface Equipotential surface is nothing but the surface on which electric potential is same. V value will be same at every point. Then such surface is said to be here equipotential surface. This is one uniform electric field. Uniform electric field andre ಏನು? Sir, uniform electric field is nothing but wherever it may be, the magnitude of the electric field is same. Such field is said to be here uniform electric field. For visually uniform electric field, how we can draw means uniform electric field for visually we can draw with equidistance line. With the equidistance line, if you draw means then that's said to be here uniform electric field lines. See, these lines are completely represent here electric field lines, electric field. And thereafter, at this point, if you see here, now this is plane A, this is plane B, and this one is nothing but plane C. Totally 3 planes I have taken. 3 planes I am considering here. Now suppose if you take here, at this point, at this point, at this point, at this point. 4 points I have considered on this plane. At every point on this plane, what will be same means here potential is same. That's why this is nothing but one of the equipotential surface for this electric field. Now here to here distance will be increases. So here on this plane, wherever it may be, on this complete plane, wherever it may be, if the potential is same means this is also equipotential surface for this electric. Now this is also like this one. Now if you take here, in case of this one, what we can write? Now potential is nothing but VA, potential is nothing but VB, potential is nothing but VC. On this plane surface, wherever it may be, potential is same. On this plane surface, at every point potential is same. On this one, potential is same. But okay, potential is different from first plane to second plane to third plane. Okay, first plane to second and first second to third. Okay, electric potential is same. ಒಂದೊಂದು ಪ್ಲೇನ್ ಮೇಲೆ ಒಂದೊಂದು ತರ ಏನಿರುತ್ತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರುತ್ತೆ. ಓಕೆ, ಬಟ್ ಆ ಪ್ಲೇನ್ ಮೇಲೆ ಯಾವುದೇ ಪಾಯಿಂಟ್ ಹತ್ರ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಏನಾಗುತ್ತಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗಲ್ಲ, ಪ್ಲೇನ್ ಟು ಪ್ಲೇನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ಡಿಫರೆಂಟ್. But on the plane, electric potential is same. So here, this is nothing but VA is not equal to VB is not equal to VC. ಈ ಪ್ಲೇನ್ ಮೇಲೆ ಇರೋದು ಪೊಟೆನ್ಷಿಯಲ್ ಈ ಪ್ಲೇನ್ ಮೇಲೆ ಇರಲ್ಲ. ಬಟ್ ಈ ಪ್ಲೇನ್ ಮೇಲೆ ಯಾವುದೇ ಪಾಯಿಂಟ್ ಅನ್ನು ತಗೊಳ್ಳಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಯಾವ ತರ ಇರುತ್ತೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇದು ಸರ್, in case of uniform electric field, they may ask one more question. What is the shape of equipotential surface means? This is nothing but here plane we can take as. In case of point charge, the shape is nothing but what we can take, spherical we can take as. Spherical is the equipotential shape. Next thereafter, dipole is nothing but two charges are equal in magnitude, opposite in sign. One is positive charge, other one is negative charge. If you take like that means then both are called as here unlike charges. Both are unlike charges. In case of a dipole, how to draw the equipotential surface means we can draw the equipotential surface like this. In this diagram you have to observe only one thing. What is that means? In case of one is positive charge, other one is nothing but negative charge. One is that means dipole. If you take dipole means in that case in between the two charges, this is the plus charge, this is the minus charge. In between the two charges, see, we can see there is a gap. At the same time, in between the two charges, the surfaces are very narrow. Like this. See, from surface to surface, gap is very small. Here, surface to surface, gap is very small. Next, outside of the charge, that means beyond the charge. Either you take it this direction or this direction. In this direction, what is there means? Lines are having wide space. Like this will be there means here gap is more marked. In this case, what happen means now this is nothing but equipotential shape of the electric dipole. They may ask for one mark. Draw the equipotential surface for a dipole for unlike charges. Draw the equipotential surface for like charges. They may ask the question like this. In that case, you have to draw them. For like charges means here in between the charges, narrower surfaces we have to take. Next, outside, we have to take. In between these two, electric field is maximum. Outside of this one, electric field is lesser. Now here crowded is there, lines are crowded is there, because of that electric field is maximum. Next, sir, in case of like charges, how to draw the equipotential surfaces? Quite opposite path for dipole. For unlike charges, like charges, the diagram is quite opposite. Here, in between the charges, the lines are crowded here. But in case of like charges, lines are not crowded or spatially. Here spatially, surfaces are drawn, but here, surfaces are drawn crowded. In case of positive or negative, between them crowded. In between like charges, in between the charges, lines are widened. Spatially, they have arranged like this. Now, this is nothing but equipotential surfaces. Very important point. They may ask the question. It carries 1 mark or 2 mark also. How they may ask the question, I will explain. Now, very first one, if you see here, what is the very first question is nothing but define the equipotential surface. You have to write the surface on which electric potential is constant at all points on it. Such a surface is said to be equipotential surface. If you draw some number of equipotential surfaces means you have to draw it like this. And thereafter, they may ask another point. What is the point? Means what is the, for example, if you just look at here one, this is nothing but one equipotential surface is there, which is nothing but like this. Now this is the equipotential surface. Now on this equipotential surface, I am considering there are how many points? 2 points. This is the point A and this one is nothing but point B. At point A, electric potential is VA. At point B, electric potential is nothing but VB. So this is the equipotential surface. On the equipotential surface, wherever it may be, electric potential is same. That means electric potential at point A is equal to electric potential at point B. Now the question is nothing but what we have to do means, suppose if you move the unit positive charge from A to B, from A to B, if you move the unit positive charge A in the big move ಮಾಡಿದ್ವಿ. A in the big move ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, ಇಲ್ಲಿ ವರ್ಕ್ ಮಾಡಬೇಕು ಅಲ್ವಾ. ಆ ವರ್ಕ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ 0 ಆಗುತ್ತೆ. ಏನಾಗುತ್ತಮ್ಮ, ವರ್ಕ್ is nothing but 0. That means they may ask the question, what is the value of work done to moving the unit positive charge on equipotential surface from one place to another place? Like that they may ask the question. So work done is 0. Sir, why the work done is 0? Okay, from the definition of potential we are having, okay, potential equal to work per charge. Now from this one, work is equal to what we can write? Potential into, okay, charge. Right, here potential means potential difference we can take in order to move the charge from one place to another place. Right, here from this one we can write here this is A and B. Potential difference, suppose if you take it here means, okay, VA minus, sorry, work done is equal to VA minus VB, okay, into charge we can write. Potential difference both are same, okay, same values to subtract ಮಾಡಿದ್ರೆ 0 into charge. So work done is nothing but 0. Work done is 0. In order to move the unit positive charge from one point to another point on the equipotential, the amount of work done is nothing but 0. Work done ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ 0 ಆಗುತ್ತೆ. That is the first point. Here some important points I am going to explaining. Those important points by listening in video, you just make a note in your notebooks. Right? What are those means? Very first point I am going to tell you here. Okay, what is that means? Equipotential surface. In case of equipotential surface, first important point, no work is required to move the charge from one point to another point on the equipotential surface. Equipotential surface ಮೇಲೆ one point ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಗೆ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನು ಬೇಕಾಗಿಲ್ಲ, ವರ್ಕ್ ಮಾಡೋದು ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ದಟ್ ಇಸ್ ದ ಫಸ್ಟ್ ಪಾಯಿಂಟ್. ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್, ಓಕೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್, ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ electric field lines are always normal to the equipotential surface. For example, if you take this is the equipotential surface, at this point the direction of electric field is normal. Here you draw the perpendicular line tangent. Now for this tangent electric field line is normal wherever it may be. Here you take it, okay, for this point electric field direction is nothing but, for this point electric field direction is normal. That means electric field lines are always normal to the, okay, equipotential surface. Equipotential surface ge ಏನಮ್ಮ electric field lines ಯಾವ ತರ ಇರುತ್ತೆ, normal. So second point is nothing but electric field lines are always normal to the equipotential surface. That is the second point. Third point is nothing but, okay, what is the third point? Let me see. Third point is nothing but two equipotential surfaces, they never intersect with each other. ಎರಡು equipotential surfaces ಏನಾಗಲ್ಲ ಅಂದ್ರೆ ಒಂದು ಇನ್ನೊಂದು intersect ಆಗಲ್ಲ. Two equipotential surfaces, they never intersect with each other. Okay, that is also another point. Why? Because means two different equipotential surfaces are having different potentials. If they intersect means, okay, at that point they must have the same potential, so which is impossible. That means two equipotential surfaces, they never intersect with each other. Now this is the third point. Now first you write equipotential surfaces definition. Thereafter, it's a definition. Thereafter, in different cases, you draw the diagram. Thereafter, okay, in down, afterwards this, you put the heading, important points about the equipotential surface. First point you write it, no work is required to move the charge from one point to another point on the equipotential surface. Or, work done to move the unit positive charge from one point to another point on the equipotential surface is 0. 0, you write. Next one, second point, okay, electric field lines are always normal to the equipotential surface. Third one is nothing but, okay, two different equipotential surface, they never intersect with each other. Okay, that is also another point. Yes, keep it. Right, any more doubts? You just ask me. Right, next the topic is, students, relation between the electric field and the electric potential. Now this is very important mark for how many marks means 3 marks. 3 marks important question. Okay, this question will carries 3 marks in examination. That's why important question. Okay, just to listen the question. Okay, it is going to finish. Right. Thereafter, just to listen. Here I am going to take to derive the relation between electric field and our potential. 2 phases I have taken, equipotential surfaces I have taken. Now here you are observing. Now this first one is nothing but equipotential surface A, and the second one is nothing but equipotential surface B. And thereafter, here the potential surface. These 2 potential surfaces are having the potentials V and V plus delta. First one is nothing but V, and second one is nothing but V plus delta. V is nothing but equipotential surface. That means E second B is having the potential, total potential is nothing but V plus delta V, and the first one is having the potential V potential A is having. That means compared to this one and this one is having some change in potential value. Right, thereafter, here on the equipotential surface, see there is a center point. Okay, at this there is another center point is there. Is it? Now, actually, previously I have told one point. Second point in equipotential surfaces, important points in important points. Second important point I have told. What is that means? Electric field line is always normal to the equipotential surface. Now, for this equipotential surface, the direction of electric field is nothing but how we have to draw. Normally we can draw. Now see, this is nothing but direction of electric field. Okay. Now thereafter, that means if you take either this equipotential surface or for this one, electric field is normal to this surface. Now thereafter, here we have to move the unit positive charge. From where to where? We have to move the unit positive charge from equipotential surface B to equipotential surface A. Both are having different potentials. Okay, right. Here I am going to move the charge from where to where means from here to here. In that case, okay, how much distance here charge is moving? Charge is moving a small distance, that is nothing but delta. Now you just look at here. Work done. Work done. Work done. Work done. Needed to move the charge, from B to A, from equipotential surface B to A. If you wanted to move the charge means you have to do the work. Now for a small distance, dl distance, the amount of work done is nothing but dw. That means delta w is equal to, we can write here E bar dot, okay, delta L bar, E bar dot delta L bar, E bar dot delta L. Next, thereafter, you just see here, why we have taken E here? Electric field E is equal to force per unit charge. Force per unit charge means we have to take electric field. E is equal to force per unit charge. Unit charge value is 1. So force is equal to electric field. So we can write it like this. Now from this one, E delta W is equal to, we can write E into delta L. We can write in which form means. Okay, that is nothing but magnitude form. Right? Just to take it as equation number 1. Right, thereafter, by the definition of electric potential, by the definition of electric potential difference. What is the electric potential difference, ma? Electric potential difference is nothing but the amount of work done required to move the charge from one point to another point. One point ಇಂದ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಗೆ ರೈಟ್ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಮಾಡಬೇಕಾಗಿರೋ ವರ್ಕ್ ಡನ್ನೇ electric potential ಅಂತ ಕರೀತೀವಿ. Of course, that is nothing but delta W is equal to what we can write. Electric potential is equal to electric potential difference from VA to VB. Sorry, VB to VA. We can take this. Right, from this one, potential difference into, we can write right. Amount of work done is equal to VB minus VA. Here you may get here, that is nothing but E into delta cos 180 also you may get. Cos 180 value means nothing but minus 1. Why? Because means, okay, electric field direction is like this is there, but charge is moving in which direction? Downward direction. That's all. Okay, right. From this one, dW is equal to what we can write. VB is nothing but, we can write V plus delta V minus VA value is nothing but, see, this is the VA. VA value is nothing but, okay, we can write V, we can write for A surface potential is V, for B surface V plus delta V. So minus and plus both are cancelled. Delta W is equal to, we are having here delta V, we are having, this is equation number 2. Now just look at here, from equation 1 and 2 we may have, right? Here ನೋಡೋಣ, ಇಲ್ಲಿ cos 180 ಯಾಕೆ ಬಂತು? E bar dot delta L bar is nothing but E delta L cos theta. Cos theta is nothing but, theta is nothing but 180 degree. Electric field direction is upward is there. Charge is moving from where to where? From charge B to, sorry, surface B to A. So ಈ electric field ಗೆ opposite direction ಅಲ್ಲಿ charge move ಆಗ್ತಾ ಇದೆ. ಅದಕ್ಕೋಸ್ಕರ both are in opposite direction means angle is 180 degree we have to take. Now from equation 1 and 2, minus E into delta L is equal to, ಇಲ್ಲಿ ಇದು ಎರಡು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಡೆಲ್ಟಾ V ಆಗುತ್ತೆ. From this one, E is equal to, ಈ ಮೈನಸ್ ಈ ಕಡೆ ಬಂದ್ರೆ minus delta V divided by delta L, we can write. Now this one is nothing but here relation between electric field and potential. R over R, if you write to in terms of magnitude, okay, E is equal to magnitude of minus delta V bar V divided by delta L. Okay, this is nothing but here, right? Here delta V divided by delta L is nothing but what we can call it as means potential gradient. That means electric field is equivalent to negative of potential gradient. We can potential gradient. We can. Sir, potential gradient andre meaning ಏನಂದ್ರೆ potential along the distance, potential along the length. Okay, that is nothing but potential gradient. ಇದೇ ಈಕ್ವೇಷನ್ ನೀವು ನೀಟ್ ಅಂಡ್ ಸಿಇಟಿ ಅಲ್ಲಿ ಯಾವ ತರ ಕೊಡ್ತಾರೆ ಅಂತ ಬುಕ್ಸ್ ಅಲ್ಲಿ E is equal to minus dV by dx, E equal to minus dV by dr, okay, distance, dV by dx, dV by dr minus dV by dl ಅಂತ ಕೊಡ್ತಾರೆ. dr delta ಏನು ಕೊಡ್ತಾರೆ, that is also correct. Okay, this is nothing but relation between electric field and electric potential. You just remember work done needed to move the charge from B to A. B to A ಗೆ charge move ಆಗ್ತಾ ಇದೆ, so 180 degree ಆಗುತ್ತೆ. So first equation. Now by the definition of electric potential difference, here we are having potential difference equal to what is that, ma? Okay, that is nothing but work done is equal to VB minus VA also we can write. Any doubts if you are having, just call me, okay, to my personal number. Yes.